we have the advantage that we've been through this once before in learning about notation. That little example we just did with velocity at least gives us a rationale for why we might want to do area under a curve. In this case, the area under velocity gave us the distance the car traveled. So at least we've started with a little bit of a piece of why we might want to do this. Now you might be sitting there going, that still doesn't convince me. I still don't want to do this. And then I'd say, well, what the heck did you sign up for this class for? But you know what I mean? That's our rationale. That's our rationale for doing the area underneath the curve, at least to get us started. Now we'll come up with more, things where this idea is useful. Okay, so this is our definition. Definite integral is just the area between the function and the x-axis. Okay? Now, this is the symbol. It's kind of this S-shaped thing. Notice the A and the B. Notice their location. We always read this as the integral from A to B. It's always from the bottom number to the top number. Now, they won't always be in the right order, though. And we'll talk about that here, well, hopefully if we have time today, but it's in your section. On a few of the homework problems, you may have to read some examples in the section to get this, but basically the idea is this. We would say the integral from A to B. If these two numbers were ever flip-flopped around, like backwards, like the example we're going to do in a minute is the integral from 2 to 5. If they were ever flipped around and said from 5 to 2, well, then it's just opposite. The answer is just opposite of what you would normally get. And we'll talk about what that means by opposite here in a second. But this is the order we want them to be in. Okay? All right, so let's say you had this homework problem right here. The integral from 2 to 5 of the absolute value of x plus 1 dx. Now, the only thing we know how to do right now is graph. Just like when we first started with slopes, we did them all with graphs at the beginning. There's no rules, even though I know we said antiderivative might be involved somehow. We're not getting into that yet. We're not ready for that. So everything's just going to be graphical. So what you need to do is graph this. So you need to say, well, this would be the x plus, this would be the v graph shifted 1 to the left. And the v graph has a slope of 1 on the edges. So it's going to go up that way. And it's going to go up that way with a slope of 1. Now, we go over here to 2. And we go over here to 5. This is our answer to that problem. We're looking for this area right here. Well, it's just a trapezoid. So we can do that. It's geometry. So, 1/2. What are my two parallel sides? I think that's 3 and 6. We can just plug in a 2 there. Plug in a 2, it'd be 3. Plug in a 5, it'd be 6. So it's 3 and 6. And then what's the height of that trapezoid? It'd be this across here, right? It'd be 3. So 3 plus 6 is 9. 9 halves times 3 would be 27 halves. And that's good enough. That's all you need. Now, like I said a minute ago, if this would have been backwards, if this integral would have had the 5 down here and the 2 up here, we call that backwards. Because we always want to read from down here to up here. So this integral is from 2 to 5. If we flip those, then we'd be talking about the integral from 5 to 2. What we would do is make that negative. It is possible to have a negative area. So the answer would have been negative 27 halves. Okay? And that's just a rule that we have to just understand that if it's backwards like that, we make it negative. All right. Now, here's a couple of little, rules we need to write down. Let's take them one at a time here. These are connected to our derivative rules. And they're the same with integrals. If I'm adding two functions together, like x squared plus sine x, if I'm adding them together, then I can do their integrals separately, just like I would do their derivatives separately. I can split it into two integrals. That's all that's saying. I'm going to show you an example of where we would use this here in a minute. All right. This second rule says that if I have a function with a constant multiplied in front of it, then I can just pull that constant out in front. Now that's just like the derivative rule that said if you have a constant in front of the function, it just hangs out there while you do the derivative. Well, it's the same thing here. But instead of just saying it hangs out, we're actually going to pull it out in front of the integral symbol. And then we'll do our area. And then tack that on. Now it makes sense because the constant in front is just going to stretch the graph up. Say you stretch it by a 3 factor, it's going to make the area 3 times as much. Here's an example problem that I want to show you that you might have on your homework. So let's say I told you this value right here. Now why would I have to tell you that? Well, it's a parabola. And that's curved. We don't know what the area would be from 2 to 4 on a parabola. That's not a trapezoid because the top part of it here is curved. That's not a geometric shape. We don't know what that area would be. We will eventually, but not now. So I'll just tell you that's 10 in the directions. All right. So now I want you to do this integral. Well, we're going to take the 2 rules we just wrote up there. First of all, I'm going to split this into 2. So I'm going to go integral 2 to 4 of 3x squared dx. By the way, the dx, while I'm writing, I'll talk about this. The dx, think of it as just with respect to, like when we do our slope, dy over dx. The dx down there is just with respect to x. That's all that dx is. It's going to have important meaning later, so we won't worry about it till then. Okay? Josiah, getting this down? Okay? There's anybody take notes on the calculator for. All right. So on this first one, I would pull that 3 out in front. Right? That's the other rule we just learned. And just pull that 3 out in front right there. See what I did? So the first thing I did was split them apart, which was the first rule I wrote up there. The second rule is where I just pull a 3 out. Now, what do you notice about this integral, this first integral right here? What do we know about that? We were told that was 10. So I got 3 times 10. And then what about this integral here? Well, that's the function 4. What would that graph look like? What's the graph of 4 look like? Horizontal line at 4. So what this would be a line at 4, and it would be the area from 2 to 4. Well, that'd be a rectangle. What would be that area? Be 4 tall, 2 wide. It'd be 8. So 3 times 10 is 30 plus 8. This integral would be 38. So see how we can use those rules I just mentioned, plus some simple functions we can just graph and get their area that way. Now x squared we wouldn't be able to because it's curved. We wouldn't be able to do that. All right, on that homework sheet I gave you, and a few of these homework problems you may have to look back at some of the examples because we got rushed here at the end just a little bit. Now we still haven't done everything that's in this first section. So the top line on that assignment sheet, the top line on the assignment sheet, we're not going to do them all, but just the top line up through 36. Up through 36. Now most of these are pretty quick, and you count some squares, you make a quick graph, maybe you just, there's not a whole lot going on there, but it's understanding the notation. That's the key. Getting comfortable with the notation. So the first line through 36 is your assignment for Monday. We'll start going around checking homework and that kind of stuff here again. Yeah, put the hats away, please. Sorry that I was going to show you a thing on there, but we'll get to that on Monday. We worked pretty hard today. Why don't you just take tomorrow off?
Good thing you don't have to go watch
You were skipping today?
UNO?
I know, I was so, why, I heard there was a chance that they might qualify. How about you guys, the girls did?
I did, team did.
You did?
Glad to be there at 6:30 in the morning. I said, get up to the next person.